Hello everybody. Today we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is practice problem 1.5 and the question is to find the power delivered to the element in example 1.5 at t equal to 5 millisecond if the current remains the same but the voltage is V equal to 2I and part B V equal to 10 plus 5 into integral limit 0 to t I dt volts. So two parts of questions are asked, okay, with the two different values of voltages. But here we need to refer example 1.5. In this, we need to refer the current I because the current remains the same. That is given, right? So we need to refer this current I. I is equal to 5 cos 60 pi t amps. Okay, this is the only thing we need to take over here. So I equal to 5 cos 60 pi t amps. So the formula to find P is equal to V into I, the product of voltage and current. And in our problem, this V is 2I volts. Okay, so we can substitute here for that case. So that is equal to V, instead of V, you can write it as 2I into I. So this is equal to 2I square. But that I is given in our problem as 5 cos 60 pi t. Okay, but I square is there, right? So it is 2 into 5 square is 25. Then you can take it as 60 cos 60 pi into t value is given as 5 milliseconds, isn't it? So it is 5 into 10 power minus 3, right? The whole square. So it is nothing but 50 into cos square of 60 pi into 5 into 10 power minus 3. So that is equal to 50 into cos square of 60 pi, isn't it? 60 into 5 is 300, isn't it? 300 into 10 power minus 3 into pi. So this can be written as 50 into cos square of 0.35. So it is 50 into cos square 0.35 is 0.3454. So this is equal to 17.24 watts. So this is the P for the first one. So this is the answer for the first part. Now we move on to the second part. So for the B part, B is given as 10 plus 5 into integral 0 to t I dt. This much volts. Okay. So anyhow, we are asked to find out only P. P is equal to V into I. So in this V, you can substitute this as 10 plus 5 integral 0 to t I dt. Okay. This is your V multiplied by I. But instead of I, we can write it as what is given in the problem. That is given as 5 cos 60 pi t. So that can be substituted. We need to solve this. Right? So it is 10 plus 5 into integral 0 to t. T value is 5 milliseconds, right? I value is here 5 cos 60 pi t into dt, right? This should be first solved, multiplied by this 5 into cos of 60 pi t. So this is 10 plus 5. Integral of this one is, we can take 5 outside. So cos 60 pi t is nothing but minus sine 60 pi t divided by 60 pi with the limits 0 to 5 milliseconds. So that is multiplied by this 5 cos 60 pi t. Okay. So this is equal to 10 plus, in this I am going to divide this. So I am going to keep this as 5 by 12 pi. And this minus sign is here available, right? So that I can change this sign as this sign into minus. So it is minus 5 by 12 pi sine of 60 pi into t values what? When you apply this upper limit, it is 5 milliseconds, right? So 10 power minus 3, 5 into 10 power minus 3. When you apply lower limit, it is sine of 60 pi into 0 multiplied by this 5 cos 60 pi t. Okay, so this is equal to 10 minus 5 by 12 pi. This is sine of 300 pi into 10 power minus 3 minus sine 0. And we know sine 0 is 0, right? 5 cos 60 pi t. So this is equal to 10 minus 5 by 12 pi. So this is sine of 0.3 pi, isn't it? And sine 0 is 0. So 5 cos 60 pi t. So here also you can multiply this. This is 5 into t is 5 into 10 power minus 3, right? Cos of. So this is equal to 10 minus 5 by 12 pi. Sine of 0.3 pi is 0.809 multiplied by 5 into this cos of, again here comes 0.3 pi, isn't it? So it is cos of 0.3 pi. So it is 10 minus this value is 5 into 0.809, that is equal to 4.045 divided by this 12 pi multiplied by this 5 into what is cos 0.35 0.3 pi. Already we have calculated this. Five into cos of 0.35 is 0.587. So actually we need to multiply these two. So this is our B value, isn't it? So we should actually put everything within the brackets, then multiply. So this is must be governed. So this is must be first solved and then we have to multiply it. So if you go like that, it is yeah. This is 10 minus 4.045 divided by 12 pi. 12 pi values 37.7. So this thing multiplied by 5 into 0.587. So this is 2.935. Four point zero 4.045 divided by 37.7, that is equal to 0.107 multiplied by this 2.935. So 10 minus this 0.107, that is equal to 9.893 multiplied by this 2.935, that is equal to 29.035 watts. So this is the answer we got for the second subdivision. This is your answer. Okay, thank you. Hope you have understood.